Welcome to the unit on HCF and LCM. In this session, we will be looking at the lowest common multiple, the LCM. The objectives for this session are learning how to define and find the lowest common multiple using the Prime Factorization Method and the division method, and learning how to solve real-life problems involving LCM. We're now going to look at the lowest common multiple. Its acronym is LCM. The LCM of two or more numbers is the smallest number among the common multiples. Let's try to understand this concept with the help of an example. We're going to find the LCM of 6, 9 and 18. The multiples of 6 are 6, 12, 18, 24 and so on. The multiples of 9 are 9, 18, 27, 36 and so on. And the multiples of 18 are 18, 36, 54, 72 and so on. The smallest common multiple of 6, 9 and 18 is 18. So the LCM of 6, 9 and 18 is 18. And therefore, the LCM of 6, 9 and 18 is 18. We will use the prime factorization method to find the LCM of four numbers up to 2 digits. So let's take a look at an example. We're going to find the LCM of 8, 14, 16 and 34. First, find the prime factors of all the numbers. So 8 equals 2 times 2 times 2, 14 equals 2 times 7, 16 equals 2 times 2 times 2 times 2, and 34 equals 2 times 17. Now find the product of common prime factors in two or more numbers and non-common prime factors also. The 2's shown are common to two or more numbers. So place a 2 here. These 2's highlighted are also common to two or more numbers. So place a 2 here. These 2's highlighted are also common to two or more numbers. So place a 2 here. The product of common prime factors is 2 times 2 times 2. Now the 7, the 2 and the 17 are on their own. Therefore, the product of non-common prime factors is 7 times 2 times 17. Now multiply all common and non-common prime factors. And therefore, LCM equals 8 times 238, which equals 1904. We will now use the division method to find the LCM of four numbers up to 2 digits. So let's illustrate this with an example. We're going to find the LCM of 27, 36, 54 and 90. First, write down all the numbers as shown in the table. Next, divide numbers by a number which divides at least two of the given numbers. Notice that 3 divides at least 2 numbers. Write down the quotient of each number below it. So 27 divided by 3 is 9. 36 divided by 3 is 12. 54 divided by 3 is 18. And 90 divided by 3 is 30. If the number is not divisible, then write it as it is. Keep dividing until the quotient is 1. Write down the quotient of each number below it. So 9 divided by 3 is 3. 12 divided by 3 is 4. 18 divided by 3 is 6. And 30 divided by 3 is 10. We are now going to continue to divide by 3 because at least two numbers in the last row divide by 3. So 3 divided by 3 is 1. 4 divided by 3 needs to be left as it is, as 4 is indivisible by 3. 6 divided by 3 is 2. And finally, again, 10 divided by 3 needs to be left as it is, since 10 is indivisible by 3. We are now going to divide by 2, because at least two numbers in the last row divide by 2. 1 divided by 2 needs to be left as a 1, as it is indivisible by 2. 4 divided by 2 is 2. 2 again divided by 2 is 1. And 10 divided by 2 is 5. Now divide by 2, as there is only a 2 and a 5 left in the last row. 1 divided by 2 needs to be left as a 1, as it is indivisible by 2. 2 divided by 2 is 1. 1 divided by 2 again needs to be left as a 1, as it is indivisible by 2. And likewise for 5, we leave 5 as it is because it is indivisible by 2. Now divide by 5, as there is only a 5 left in the last row. 1 divided by 5 needs to be left as a 1, as it is indivisible by 5. Likewise for this one, and likewise for this one. And finally 5 divided by 5 is 1. Now multiply the divisors to find the lowest common multiple. So LCM equals 3 times 3 times 3 times 2 times 2 times 5, which is 540. We will now try to solve a real-life problem involving LCM. What is the minimum distance which can be measured with 10, 20, 25 and 30 meter long string? Let's take a look at this. Begin by writing down all the numbers as shown. And follow the instructions as in the previous LCM example. First, divide each number by 2. 10 divided by 2 is 5. 20 divided by 2 is 10. Now 25 divided by 2 needs to be left, as 25 is indivisible by 2. And 30 divided by 2 is 15. Now divide by 5, as at least two numbers in the last row are divisible by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. 25 divided by 5 is 5. and 15 divided by 5 is 3. Now divide by 2, as there are no other numbers which are common divisors. 1 divided by 2 needs to be left as it is, as 1 cannot be divided by 2. 2 divided by 2 is 1. 5 also needs to be left as it is, as 5 cannot be divided by 2. And similarly for 3. Now divide by 5, as there are no other numbers which are common divisors. We leave 1 as it is, since it's indivisible by 5. Similarly for this one, 5 divided by 5 is 1. And finally 3 needs to be left as it is, as we cannot divide by 5. Now divide by 3, as there are no other numbers which are common divisors. 1 divided by 3 needs to be left as it is, since it cannot be divided by 3. Similarly for this one here and this one here. And of course, finally, 3 divided by 3 is equal to 1. Now multiply the divisors to find the LCM. So 2 times 5 times 2 times 5 times 3 equals 300 is the LCM, and the minimum distance which can be measured is 300 meters. This brings us to the end of this session. If you have understood its contents, you should be able to define and find the lowest common multiple using the Prime Factorization Method and the division method, and solve real-life problems involving LCM. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time, so you can check your answers as you go along. Pause the slideshow whenever you need to.